Hello, Assalamu alaikum and good morning. I'm Ahmed Bawazir from Group 1, Group Assignment number 1 for Operation System Design, code Bjmp 3023. Group 1 from Group A, lecturer Prof. Dr. Lim Kong Chung. Today we are presenting about the assignment, group assignment, about the Taguchi airplanes product design. So I will present the introduction. So let's get started. This project is about using Taguchi approach to conduct an experiment about paper airplane. Genichi Taguchi contributes on quality philosophy and quality tools, where it has to focus more on making quality rather than respecting quality. Taguchi methodology has expanded experimental design beyond the realm of statistician and into the realm of manufacturing. It underlines the significance of designing quality control into manufacturing process. The main purpose of this study is to show how Taguchi fractional factorial experiment may be used in product design. The use of the Taguchi approach to parameter design in this study to determine whether a factorial level has a real impact on quality characteristic. The Taguchi method is a powerful design of experiments that enables you to optimize design for performance, quality, and cost in a simple, efficient, and systematic manner. Taguchi developed a two-step process. Step number 1, optimizing the design of a product or process by manufacturing it in the best possible way with less deviation from the target. Step number 2, to ensure produce the product are identical by designing products and processing that are unaffected by uncontrollable factors. Genichi Taguchi method can ensure the quality of design through 3 steps. Step number 1, system design. Step number 2, parameter design. Step number 3, tolerance design. The basic approach about the design of experiment consists of 4 stages. Stage number 1, planning the experiment. Stage number 2, designing the experiment. Stage number 3, conducting the experiment, and number 4, analyzing the experimental results.
Hi, my name is Nunusa binti Anwar, and my metric number is 269830. Okay, for my slide, I will present about Taguchi philosophy, which is Taguchi philosophy is the main philosophy from Dr. Taguchi, which is Dr. Genichi Taguchi, and he was introduced one of philosophy, which is Taguchi philosophy, Taguchi quality philosophy. Okay, Taguchi has tested the effectiveness of his philosophy on an airplane. Taguchi philosophy is to focus on the quality of making a product. Okay, in addition, Taguchi is also very concerned about the quality improvement, where the product that will be produced or modified will not get the same feedback from customers. Therefore, apart from product quality, Taguchi is also concerned about product improvement, because every feedback from customers will affect the company's performance. Okay, the second slide is about the concept of loss function. Okay, Taguchi loss function is a graphical representation that tell about loss. Okay, Taguchi loss function also about customer satisfaction because the feedback from customer will affect the volatility of this graph. Okay, the common thinking around specification limits is that the customer is satisfied as long as the variation stays within the specification. Okay, specification limit. Okay, look at the figure 5. If the variation exceed the limit, then the customer immediately feel dissatisfied. Okay, the specification limit divide satisfaction from dissatisfaction. Okay, for example, if the lower limit is 10 and the upper limit is 20, okay, then a measurement of 19.9 will lead to customer satisfaction, while a measurement of 20.1 will lead to customer dissatisfaction. Okay, for the next is about Taguchi method for robust design. Okay, a powerful design center to increase the critical capacity of an item or cycle. In this way, working with a customizable plan and planning simultaneously. Okay, without a doubt, this is the most effective strategy able to reduce the cost of goods and improve quality. Okay, the way for Taguchi robust design, rather than trying to control uncontrollable or overpriced factor, to even consider controlling them is to determine the advantages of control components that will limit their consequence on the item or cycle.
Next, I will present about questions number 1. What can you say about the effect of the different factor on flight distance? What level of each factor will you use to maximize flight distance? According to the experiment that our group had conducted, we found that paper airplane having different weight, stabilizer setting, nose length and wing angle had different flight distance. We found that paper airplane with longer nose had a longer flight distance compared to other paper airplane. This can be proved in the table 1. We found that in the experiment number 6, a paper airplane with a longer nose has a longer flight distance compared to other paper airplane. Moreover, we also found that experiment number 6 had the highest standard deviation compared to the other experiment and had the lowest signal to noise ratio among the experiment we conducted. In addition, the weight of the paper airplane should also be considered, as the weight of the paper airplane also affect the flight distance. We found that the paper airplane with parameter at position A1 had a longer flight distance compared to position such as the A2 and A3. This can be seen in the experiment number 2. The position of the paper airplane is at position A1 and has a longer mean distance of 384.12 cm compared to other experiment. Not only that, we also found that the less heavy of the paper airplane have the higher gravity attraction of the paper airplane to fly over a longer distance. Last but not least, we also found that the wing angle also influence the flight distance of the paper airplane. This is because paper airplane that has a wider wing angle can fly with a longer and slower condition because the air will pass through the two surface and yet low velocity as well as high pressure. And next, we suggest level 2 is the factor to maximize the flight distance, this can be observed in table 2. On the table, the nose length and wing angle at level 2 was the highest among the others level, although the weight only differ, which is 11.63 cm with the first level. So we can observe that this factor can be used to maximize the flight distance.
Hello, good morning to Dr. Ding Quang Tiong. My name is Lo Khamun with material number 271566. Today I'm going to present about the discussion and conclusion. I'm going to discuss the question 2, question 3, question 4 and question 5. For the question 2, the question given is what can you say about the effect on the factor and variation in flight distance? What level of each factor will you use to minimize the variation in flight distance? First, changing the location of weights is one of the influence of this factor on the variation of flight distance. Based on the experiments that have been done, our group has observed that the gravity of the different aircraft will affect the flight distance and floor time of an aircraft. When an airplane has a balanced gravity, it will fly a long distance and the floor time becomes long. Second is noise length. If the noise length of an airplane is long, it will be opportunity for the airplane to fly a long distance. In addition, change in wing angle also affect the flight distance of an airplane. Based on the experiment that have been done at the research site, we have observed that aircraft with a wider wing angle have a longer flight distance compared to a less wide wing angle. In addition, stabilizer wings such as up, flat, and down are also one of the factors on the variations of flight distance. After the experiment, our group has observed that flat type airplane wings and down type wings will have the longest flight distance compared to the up-type airplane wings where the flight distance is short. The level of each factor that our group will use to minimize the flight distance variation is the third level. To minimize the flight distance variation, our group recommended by changing the location of weight, noise length, and wing angle. For example, we suggest changing the weight location from A3 to A1, the noise length from C1 to C3, and the wing angle from D3 to D1. These changes that our group is proposing can actually minimize flight distance variation. Next, the third question is in the SN ratio reasonable way to capture both costs to maximize the distance and minimize the variation. Can you specify an optimal design, why or why not? Yes, the SN ratio is reasonable way to capture both purposes to maximize the distance and minimize the variation. The purpose of this SN ratio is visual the quality characteristic and process analysis of significant thinking parameters. In fact, higher SN ratio values can help to identify control the factor settings that minimize the impact of noise factors. Based on the results of the experiment that have been done, the optimal design that our group proposed is the 6 airplane. The reason our group suggests the 6 airplane is the optimal design because this 6 plane have a long noise length which is C1 compared to C2 and C3. Wing angle is at D2 which stable compared to D1 and D3. Stabilizer flaps are at B3 or wings that are down type indicated stable, and weight position is at A2 more stable compared to the A1 and A3. This This has shown that an airplane that has a long noise length and is in stable positions make it possible for the aircraft to fly a long distance and as well as 4 times. Next, the fourth question given is what types of noise variation are considered in this experiment? Based on the experiment conducted, there are two types of noise variation considered in this experiment. The first is physical environment, that is air. In fact, the air in our experiment plays greatly affect the smoke flight of an aircraft, namely the flight distance and the landing time of an aircraft. When the air is erratic, it has caused the flight distance and 4 times of its discarded plane to be different. As we can observe, the stronger the air, the farther the flight distance of an airplane and vice versa. In fact, we need to take care that there is no wind in the study area so that we can start our experiment. The second type of noise variation considered in this experiment is for the plane method. If there is a plane that is for the unbalanced, it will affect the smooth flight of an aircraft. In fact, we need to make sure the both sides of the further plane are the same. Similarly, if there is an airplane that is further incorrect or further trussed with a different design, it needs to replace with a new fantastica because the plane that is further incorrect it will interfere while flying. The last question given is how can interaction between factors be considered? The first method is to change the wing angle. Based on the experiment that have been done at the research site, we have observed that aircraft with a wider wing angle have a longer flight distance compared to the less wide wing angle, and he has a closer flight distance. The next method is changing the nose length. This nose length actually also affect the flight distance of an airplane. Based on the results of the experiments that have been made, we have observed that the closer the length of the nose of the position of the weight, it causes the wings to be wider the farther the flight distance of an aircraft. But there is the interaction between the factors that can be considered in the TAGUCHI plane experiment is to change the location of the weight. In fact, the flight distance and 4 times of an aircraft are highly dependent on the gravity of an aircraft. This because the different weights will cause the different gravity. For example, the airplane is unbalanced, it causes the aircraft to be really difficult to fly and in turn cause the flight distance is short and 4 times is fast. Similarly, when an airplane have a balanced gravity, it will fly a long distance and the 4 times becomes long. Therefore, in order to extend the flight distance and the 4 times is low, the gravity of an aircraft must be stable. Thank you.
As a conclusion, this study was conducted to discuss the factors such as weight, position, stabilizer, force, nose length, and wing angle that affect the flight distance of the airplane paper, as well as count to fall and throw the paper airplane. A total of 45 experiments need to be performed in this experiment. Repeat this experiment 5 times to understand the change needed. The optimal design proposed by our group is 6 plane because this 6 plane has a longer nose length which is at C1 compared to C2 and C3. Wing angle is at D2 which is stable compared to D1 and D3. Stabilizer flares are at B3 and wings they are downside indicators stable and weight for position is at A2 more stable compared to A1 and A3.